Okay, so in this video we're talking about variation, and there's basically two different kinds of variation. One is direct variation and inverse variation, and then we can have various combinations of these two. But what direct variation is, it's any relationship, basically any relationship where we have y is equal to some value a, x to some exponent n, where my n is a positive real number. Okay, and so we often say that y is proportional to some x to the power of n. And one of the characteristics of direct variation is that it goes through the origin. Okay, so here's an example that we can take a look at. We know a model for the cost, C, of a carpet is directly proportional to the square of the length of the wall in which the carpet is laid. The cost of laying carpet in a room with a wall of length 4 meters was 192 euros. So we want to create an equation that relates the cost and the length. Well, I know that cost is directly proportional to the square of the length, so the length squared. What this means is that there's cost is equal to some constant of proportionality, some factor multiplied by L squared. And so I know that the wall length of 4 was 192. So I know that L is 4 will give me the C of 192. So if I plug these values in, 192 is equal to K times 4 squared. I get K is equal to the 192 divided by 16. What if I use my calculator? 192 divide the 192 divided by 16 gives me 12. So I know that my equation is C is equal to 12 times L squared. Here is the relationship between the cost and the length. So think about, why would the cost be directly proportional to the square of the length of the wall? Well, if we think about what is going on here, is if I have a room, right? I have a room, here's the length of the wall, and it's talking about the cost of laying out a carpet. And so it's going to be square because this is an area. So it's really talking about an area, that there's a relationship there of some kind. So when we're looking at modeling various scenarios, anytime we model things, we should think about the geometry that's available. Think about the relationship that may exist in other aspects as well. So sometimes we deal with volume, sometimes with area, and so you should consider those scenarios. So it says, what is the cost per square meter? Well, next one is, well, if I read this equation, this here, if L is 1, it's 1 squared, so it's 12 euros per meter squared is how to read this equation. Okay, so now what is the cost of the carpet with length of wall 3.2 meters long? Well, we use our equation, C is equal to 12L squared, and I'm really looking for, my C's and L's are looking the same, I'm looking for when L is equal to 3.2. So I just plug it into my equation, which was the point of making the equation, and so if I throw that in my calculator, if I check my notes, I know that's going to be the same as 122.88 euros. And if I round that to 3 significant figures, it's 123 euros. And then finally, E part says the actual cost for a 3.2 meter wall is 125 euros. Calculate the percent error. Well, in doing this, if we look at our formula booklet has this particular formula for percent error. And I know, so my error is going to be the value, the exact value, which I know is 125, minus the approximate value. This is the approximate value divided by the exact value. And I recognize that I have it written in here backwards, but because it's absolute value, it will not matter. And so I go over 120 over the exact value, times it by 100. And if I put this in my calculator, I end up with, let's see, 125 minus 122.88 divided by 125. And if I'm going to get 1.70% if I multiply that by 100. So this is going to be my percentage to three significant figures. So in building direct variation, we have to find this constant of proportionality to make our equation, and then we use it like we would any other equation.